Welcome to Tech Primers. In this video, we are going to talk about containers along with Docker. So, if you had heard about the latest buzz term, containers are the buzz term, right? So, containers and Docker. So, if you hear to people talking about containers, you don't have any clue, right? Basically, so let's talk about containers and understand what is a container and what is this Docker. Okay. So, what are containers? So containers are nothing but lightweight image of a package basically. So what is there in the package? So you have the code, the runtime, the tools which are required for the runtime, and also the libraries which are required for the runtime. And additionally, there are some settings. So basically, container is a package or a image which has the complete set of software information which is packaged in a simple image. Okay, so that is a container. So what are the advantages of a container, right? So why container is like much talked about? Because the containers can be used across OSs. So you can use that particular image can be used in a Linux machine, or you can use it in a Windows machine, or even you can even use it in a cloud machine. Okay, also the other advantage of containers is that you can isolate the software from its surroundings. So for examples, right, you will have a development environment, you will have a UAT or a staging environment, and then you have production, right? So when you create an image, the same runtime, the tools, the system libraries are all packaged in one image. So you will test the same image across all these environments, and the lesser coupling is there with the hardware. So in general, what we do, we have a different configuration for dev, different configuration for prod and test, right? So not only the configuration, but also sometimes the runtime environment itself varies, right? Because it's there in the hardware, but container packages them all into a single image. Okay, so that is the basic idea of a container. So if you take a traditional virtual machine, right? So previously, before the machines came into picture, right? So we had these bare metals. So bare metals basically had like a hardware, and then you had an OS, and then you had an application. So basically, every application was deployed into a complete bare metal machine. Basically, you had an hardware, OS, and the app. That's it. However, the virtualization concept changed the way you deployed application. So if you see the traditional virtualization or the VM, how it is we have a server or a hardware, and then there is the host OS, so which is the OS which is required for the server to function, and then there was a concept of hypervisor. So the hypervisor will now provide us to create virtual machines. So the guest OS and the app is all virtual machine. So you can create n number of virtual machine and you can deploy your application. So this basically allowed us to segment a particular server into different machines, basically called as the virtual machines. So if you see, this is how we had been deploying our application, right? You create a VM inside a hypervisor, and this particular VM will be specific for an application, so you can install any OS in that particular VM. Okay, so this is how we were doing traditional VM management right now. So why do we need it now, right? So it was all good. So what is the product, what is the problem in that, right? So why do we need containers now? The major drawback of the visualization concept is there are lots of space which are getting wasted. If you see, there are lots of OS installations which are happening in the same hypervisor, and also the space is getting wasted. So you literally have one OS already running in the server, and then you have OS per instance, right? So that is unnecessary waste of space, and also the licensing cost associated with each OS. So there are sometimes instance level licensing which are there for OSs. So that cost is like unnecessary, right? And also the complex configuration of the VMs and the hypervisors. So that all made people think that, okay, why do we need to use virtualization? So why can't we think apart from virtualization? And that's when containers evolved. Okay, so if you see a traditional container architecture, how does it look like? You have a server, you will have a host OS. However, there won't be any hypervisor. So instead you have something called container directly, and then the apps will be hosted inside the container. So that is how it is. So this is the typical container architecture. So previously, if you had seen the VM architecture, you had an hypervisor, and we created VMs, and there were guest OSs specific to each application. So the concept of guest OS is gone now. So you have a single OS So the container is an image which takes care of all those which are required for the application. Okay, so how does a Docker container look like? So it is almost the same. The only difference is the Docker engine, which is there above the OS, which will be what you call an abstraction layer between the container and the OS. So you have a container with the app. Same way you have different containers in the same OS, but Docker engine would be the abstraction for the containers to speak with the host OS or the hardware. Okay, so what are the advantages of Docker, right? So Docker is basically very lightweight. So if you compare a virtual machine, right, a VM, so the VM has a complete OS and an app, and also the set of libraries which are required, which is so heavy. However, if you see Docker or the containers, they are very lightweight because it's just a package. It is like a zip file or a tarball. That's it. It doesn't have any OS installed. It's just a static bin or a library. Okay, and also Docker is based on open standards. See, these container platforms are based on open standards, so they can be run on all major Linux distributions and also the different OSs like Windows and others as well. Also it can be run on the bare metal as well, same with the VM. So even these container platforms can be run on the VMs as well. So instead of the OS, the hypervisor will internally have a Docker image itself, so you can do that as well. Same way with the bare metal on the cloud, so we can run containers or the Docker in the cloud. So what is basically Docker, right? I forgot to cover that. So Docker is a implementation of container platform. Okay, so Docker is evolving day by day, and also it's becoming a platform in itself. Sorry, so it's becoming a platform in itself as well. So basically Docker is an implementation of container platform, and people are widely using it now, and also, as you know, it's open source. Okay, so the Docker containers isolate the application from one another and from the underlying infrastructure. So as you had seen in the previous image, it isolates the application from one another. So you don't have different applications deployed in the same OS. Even though the OS is same, okay, it creates a container. It creates basically a boundary for your application so that you don't cross your boundary and touch the other application space. So that is what Docker helps us in doing. Okay, and also Docker provides full isolation, limit the application with into a single container instead of the entire machine. So that's what I told, right? So it will have isolation limit only to that particular container and not to the entire machine, so you don't have to worry about the space constraint. So Docker uses there is something called user space in Linux kernel, if you have heard about user space or the namespace. So Docker uses that to allocate a space for that particular image. Okay, so this is how you can use Docker. So the additional advantage of Docker is, so let's say there are two different hosts, so all are having a server, host OS, and also the Docker engines running. Now I have some containers running in the host one, and this image can be shipped from the host one to host 2. Okay, so you just create an image in host 1, the same image can be shipped to host 2, and you can get that up and running within minutes. Okay, that is the major advantage of Docker. So you just create a Docker image with a set of libraries and set of things which you need along with your application code and stuff like that. So you just create a Docker image, and that particular Docker image can be deployed into any host, and you can get your application up and running within minutes. Okay, so that is the major advantage of Docker, and that is why people are going towards Docker and its usage. Okay, and the container platform basically. So that's it about the Docker. So I don't have any hands-on as such for Docker. I have installed Docker engine, but I haven't tried it yet. I don't know whether my laptop will be able to handle it, and I don't know if it works on Mac, right? So I haven't done any detailed investigation on that, but I'll let you know once I have some hands-on experience on that. I'll just make another video. So if you like this particular video, go ahead and hit the like button. If you have any doubts or queries on any topic, give me that in the comments below. So that's it for this particular video. Meet you again in the next video. Thank you.